All right. Okay, everything okay?
We can go for it.
Okay, all right. Welcome everyone. So thank you all for joining us for today's Ocean Plastic webinar. My name is Xie Zhao, a researcher at the Marine Plastic Research Group at Jamstack. Today I'm a new member of the Ocean Plastic webinar organizers.
Okay, everything okay? We can go for it.
Working as a moderator.
Welcome everyone. So thank you all for joining us.
It's my first job in our webinars. Yeah, so it's my honor to be part of the OPW team. Today, we will have 4 speakers. So who are the 4 co-founders of the Ocean Plastic webinar? So they have done amazing jobs in the past, I think, 2 years. They worked with scientists in different fields from different countries, have contributed 20 interesting talks on the plastic marine pollution, depth pollution. So, but today is their first time giving talks in the Ocean Plastic webinars. So I would like to introduce our 4 speakers in the order of their presentations. So our first speaker is Dr. Audrey Hasson. So Audrey is the head of the GEO Blue Planet Europe office in France, hosted by Moncler Ocean International. She's a physical oceanographer, interested in tracking ocean plastic using the satellite observations. So our second speaker is Dr. Delphine Lobelle, is a postdoc researcher at the University of Utrecht, Netherlands, in the tracking of plastic in our sea teams. It's a famous team, and she's also a physical oceanographer modeling the 3D transport of ocean plastics. Our third speaker is Dr. Yuta Nakajima. Yuta is the leader of Marine Plastic Research Group at the Japan Agency for Marine Earth Science and Technology. Yuta is a biological oceanographer with interest in the fate and the impact of plastic debris in the deep sea environment. Last speaker is Dr. Takenta Chataka. Takenta is a postdoc researcher at the University of West Cape, South Africa. She is a chemical engineer focused on the sustainable waste management. Okay, that's all of 4 speakers and 4 co-founders. So after the presentation, there are 20 minutes of the QA. So if you have a question, please log on to the Slido, sli.do, enter your question. The password is OPW. You can also find a link for the Slido at the bottom of the screen. So in the Slido, you can ask your questions during the presentation and vote your favorite questions. So we will ask your question after the presentation. All right, let's get started. So Audrey, you now have the floor.
Thank you for the very nice and great presentation. I'm going to share my screen, and you can tell me if everyone can see it. Let me first switch into full mode. Can you see full mode, or can you see the presenter mode?
Yeah, right now it's the full mode. It's good.
Full screen.
It's
okay, perfect.
It's the presenter mode though. Yeah.
It's okay.
The other one.
Is that here? Yeah, swap. Is that better?
Perfect.
Yes.
Yes, perfect. Thank you. So I'm going to be talking today about what's been, taking my entire time for the last year and a half, 18 months. So now I'm the GEO Blue Planet European coordinator. And in particular, I lead the Marine Litter Working Group. And we're working on supporting, as an interim, the coordination office for the Integrated Marine Debris Observing System, but I will get back to this. First of all, if I can change slides. I can, perfect. The GEO Blue Planet initiative. So GEO is the group on Earth observation, and this group, that is what I call our mothership, looks at, like all the different usage of Earth observation, from agriculture to rivers and so on, urban areas. But the GEO Blue Planet one is the ocean and coastal arm of the group on Earth observation. And what the GEO Blue Planet initiative does is that it supports the sustained development and use of ocean and coastal observation for the benefit of society. We are a network of ocean and coastal scientists. We have also social scientists with us, and of course, end user representative from stakeholder groups. So what we call stakeholder groups here can be representative from UN offices, like the regional UNEPs, or the regional IOC, the Intergovernmental Ocean Commission. But we also have end users such as commissions for regional fisheries, or the hotel industry, and so on. We have two main offices, one in the US that was created in 2015, and the one in Europe that I lead, that was created in November 2020. And what we do really is that we focus our actions around three, what we call core action areas, which are stakeholder engagement. We want to know what the information needs are. We also focus on cooperation and co-design. We need to be building the tools that meet the information needs. And then the last, but of course not least, because without this, it doesn't work and doesn't flow. We work on capacity development to make sure that we strengthen and transfer capabilities that are available. We focus on a wide range of different topics, but we have, like 10 running thematic working groups. I just gave you like a few examples here. Marine litter, of course, that's the one I'm going to be talking about today. Fisheries, sargassum, oil spills, and eutrophication. So the Marine Litter Working Group, we are a network of 11 scientists and stakeholders, and that is led by the European office of GEO Blue Planet. And we have 4 identified goals. The first one is to identify data and information gaps when it comes to marine litter, provide networking and coordination support, identify best practices to inform policy recommendation, but also to measure the impact of mitigation strategies. And then last, it is to support the monitoring and reporting of SDG 14.1. So SDG 14.1, the SDGs are the Sustainable Development Goals, and the 14 is, more. I think it's life underwater, and 0.1 is directly linked to marine litter. So, as part of this working group, we act as the interim office for the imdust, Integrated Marine Debris Observing System. And what is this this beast? The big aim of this group is to strengthen the scientific knowledge and support strategic actions related to marine debris pollution. So the main goal is basically to create one global observing system that goes, all across the ocean, all across the different fields and interests of people, for 2 main reasons. I would say 3 actually. The first one is, of course, to support science, because if we want to go further into our knowledge and understanding of, where goes the marine debris and what are the impacts and so on, of course, we need observation. But also we need observation as part of the UN Decade Ocean Science for Sustainable Development goals, the SDG 14.1 I was just talking about before, to prevent significantly reduce marine pollution. So you need basically information to know where we are and to see if the policy that are in place actually have an impact. And that's actually linked to the second or third reason, which is in March 2022, 175 nations at the 5th session of the UN Environment Assembly decided to start working on an historic resolution to end plastic pollution and forge an international legally binding agreement by 2024. So to achieve this very ambitious goal, there is a critical need for accurate, up-to-date information on marine litter, plastic pollution, and related topics, which means to make, I would say, an informed legally binding agreement, you need observation. And to see if, the positive impact of this binding agreement, you need, again, observation. So imdust is this group that mobilizes a wide range of experts, one of which is Ryota from this group, at the international level, and we build an existing observing system. Of course, imdust is not gonna, recreate the entire system and network and community of practice and civil society. The idea is to bring everyone together under one roof to be able to integrate all these observing systems. And the idea is to help set up also new ones where needed, because of course there isn't observing systems everywhere. So what are we talking when we're talking about marine debris monitoring? Because I think that's the core of the idea of the imdust, is that we basically start and stop at marine debris monitoring, but we need to know what we're talking about. And that's where it gets really complicated. What are we talking about? Are we talking about floating or beached plastic? Are we talking about specific items, such as, I don't know, water bottles, toothbrushes, and so on? Are we talking about specific size ranges? Are we going from nano to mega, or are we, focusing only on micro plastic? And then what parameter are we using to characterize this marine debris? Are we talking about number of particles per volume? Are we talking about mass of debris? Are we talking about the type of polymer? Are we talking, like polystyrene or polyester? What are we talking about? Are we looking for the presence of additional chemicals, what we call, the additives, or any toxin that is adsorbed on the surface of the plastic? Are we talking about the pathways, meaning where does the plastic comes from and where does it go? But we're also talking about where are we looking for this plastic? Where, when we talk about a global integrated marine debris observing system, where are we looking? Are we only looking at the sea surface? Should we also look at the seabed? And I'm sure Ryota is going to tell us, is going to show you why we need to look at the seabed. Are we talking about river, shorelines, water column, biota, of course? And when? Like right now, what we have is specific, scientific experiments. They're non-recurring, which means they're just like once or, every, a few times per year. Are we talking only at normal conditions, or do we want to explore extreme conditions such as tsunamis? Do we want to like flooding and so on, or do we want repeated surveys, seasonal, maybe monthly or yearly, to have a better picture at the long term quantity of plastic that is in the ocean? But in the end, it comes down to why. You need to first understand why you want to monitor this marine debris to understand what, where, and when you'll be, in monitoring this plastic. And imdust aims to move from monitoring for answering a set of questions. So you have, like scientists have this set of scientific questions, and then they build experiments to answer this question. But we want to move from that to monitoring for the benefit of all. And then that means we're going to have to figure out, what actually benefits everyone. What kind of, what are we measuring, where, and when again? So when we talk about monitoring marine debris, we have three big families that will be very well represented in the next three talks. We have in situ collection and sampling analysis, where we go with nets or bottles or actually underwater vehicles like Ryota. Remote sensing imaging, where we do when we look with satellites or planes or even like human observers. And the last one is the particle drift modeling, and Delphine will talk about this. What we need to keep in mind is all this observation that we and modeling that we want to bring together, they do all benefit from one another. Like looking only at in situ or only at modeling will not do the job. We need to take everything into account, but everything, have different ways of organizing themselves. So basically, IMdust calls for an integration of remote sensing, in-situ observation, modeling input to provide a spatially coherent coverage and consistent surveying time series from local to global scales. Of course, we need to use models. That's always very important for the optimization of the design of the monitoring system, but also, of course, for the information itself, the interaction with the other observing system, like how do we measure physical but chemical, biological processes, the engagement of volunteer and citizen scientists initiative, the establishment of best practices when we talk about these methodologies, the different methodologies that exist, and also try to put all this data together to synthesize this data to support research, but also different needs. I'm going to go really fast here, but the idea is just to tell you that the IMdust, of course, is not only GEO Blue Planet. The Interim Coordination Office is GOOSE, the Global Ocean Observing System from WMO and the IOC and UNEP and GEO Blue Planet, but we have a really strong interim committee with people from IFREM Air France, from the University of Sao Paulo, University of Hawaii, the Sea Education Institution in the US, the Italian Research Agency, the European Space Agency, and the European Commission. So we are a big group, and we're growing. And this data, I'm going to skip this one, but this data will actually feed the GPML. So GPML stands for Global Partnership on Marine Litter from the UN Environment Program. And this data will actually feed this platform that they're developing that will provide the data and information across the entire marine litter and plastic pollution life cycle to support these policymakers and decision makers and so on. So thank you very much for listening to me today. There are much more to say about this. First of all, you can find information on our website at geoblueplanet.org. Bear with us on this one. At the end of the month, we should have the new version of the website with all the updated information. But until then, we have two big events coming up. The first one is our GEO Blue Planet 5th Symposium from the 24th to 28th of October in Accra. And we will be flying in ECOPS. We will be talking about all the different thematic areas that GEO Blue Planet works on, but especially marine litter, because it is a very important issue, challenge in Western Africa. And we're also having this event at the end of June that is integrating marine litter monitoring to inform action that will be held at the UN Ocean Conference. Thank you very much. Send me an email or shoot me anything if you want to participate or if you want to collaborate in the future. Thank you.
Okay, great. Thanks, Audrey. So thanks. The slides provide some lots of information about the GEO Blue Planet. Thanks again. So,
thank you.
Okay. Okay. Let's turn over the time to the Delphine.
Perfect.
Delphine,
Just share
can you share your screen?
Yes. 1 second. Yeah. Okay, you should be able to see the big screen now, right?
Yes.
Perfect. Okay, so thanks a lot, Audrey. It's always interesting. I think it's really great that we're doing one of these, presentations that's with all of us, because we're always hosting, and so now we can finally present a bit of our work. So that's that's really great. And I'm also just reminding everyone who is joining live that you can ask your questions on Slido. So you just type in sli.do, and then the hashtag is OPW for Ocean Plastic Webinars. So yes, I am a physical oceanographer, and I'm a postdoctoral researcher at Utrecht University at the Institute for Marine and Atmospheric Research. And even though I am normally tracking the ocean plastic transport using models, I'm now going to show you a study that's a little bit different, because we collaborated with the Copernicus Institute of Sustainable Development at Utrecht University. And we wanted to try to combine some modeling with some of the material flow analysis of Dutch plastic waste in order to estimate how much is actually produced and where it all goes. So this is really what the aim was. So to estimate the annual mass flow of Dutch plastic waste. And the question that we wanted to answer is how much Dutch plastic waste is properly managed and how much is actually leaked into the environment. Because a lot of the time we're looking at, where the plastic ends up once it's in the ocean, but to actually try to have a clearer estimate of how much actually ends up in the ocean, we need to see how much is leaked in general, in total, in the environment. And this paper is currently under review. And so this is just to show you all of the co-authors that have been taken part in this and contributed to this work. So I'm now going to jump straight into the results because we only have 10 minutes and I want to also show a few of the other things that I've been working on. So this is basically a Sankey diagram, and maybe you haven't really seen this before if you're more focused on kind of the movement of plastic, but this is a very clear way of seeing kind of the input and output of a model or of some estimates when you have different categories. And so on the left-hand side, it's basically the categories of all the sources of plastic that we could find. So we did a lot of interviews with different stakeholders. So depending on the particular category, we would either have to look at different ministries and governments or look for reports online and then try to interview the authors of that. And then finally, we look at where all this plastic ends up and which ones are properly managed and mismanaged. And so you'll see on the right-hand side, all of the ones that are either properly managed or that are unreported, and then the amount that is actually leaked into the environment. So there are about 2,000 kilotons of Dutch plastic waste that were generated in 2017. So it's important to mention that, due to data availability, the year that we chose that had the most data available was 2017. And an estimate of between 0.2 and 1% of the total actually leaked into the environment, which you might think sounds quite small, but when you see the amount that is generated, it can actually end up being quite a significant amount. The largest sources came from imported plastic scrap. So a lot of there's a lot of trade of plastic in general in the world, but Rotterdam, so in the Netherlands, it has one of the largest ports. So this is why there's a huge amount of import and export of plastic in the Netherlands, of plastic waste. Then household plastic packaging, textiles and clothes, and household plastic non-packaging, so other items that come from households, was these four categories made up almost 75% of the total of the sources. And when you look at the destinations, 38% were sent for recycling, 29% to incineration for energy recovery. So in the Netherlands, there is no incineration just for loss. So there's always this energy recovery that occurs. And 20% of it was sent for export. And then we ran a model that was based on a Law et al. Paper. I'm going to show it in the next slide, but to estimate how much of that export is actually leaked into the environment. So in order to get these estimates, so for this Sankey diagram, we went through we combined two different methods. So the first one is a material flow analysis. And so here we were really looking at the amount of plastic waste that was generated, collected, and reported, and then sent to be processed. So if, for example, there is plastic waste that is generated and collected, but it hasn't been written down anywhere, so there are there's no actual record of this collection or of where it goes, then it's very hard to add it to this kind of an analysis. So, when thinking about if this can be applied in different countries, this is a very important part of it, right? So this goes back to what Audrey was just saying about data and really collecting and reporting data being crucial for any of these types of analyses. And so, as I mentioned, we were looking at different reports and statistical databases, whether they were kind of European level or national level. And there is quite a lot of information about plastic waste in Europe in general, so the reporting of it. And then for the leakage model, so the amount of exported Dutch plastic waste is reported on the UN Comtrade data. And then there's a breakdown of how much is actually sent to each country. And so depending on whether those countries have a proper waste management or a very poor waste management, then we could do some estimates based on this Law et al. 2020 paper that they did a very similar analysis, but for the US. And so then you can do look at a range of how much of that waste is actually going to be properly managed in that other country that is importing this waste. And you'll see in the next slide, I really show these in a schematic, how much of it can actually be leaked into the environment. And then the littered plastics. So here we really wanted to look at observational data that was collected in the Netherlands. And as you can imagine, it's still very sparse. So we really focused on the amount that was found on beaches and on riverbanks. And here are the different papers that we used to base this part of the analysis on. And this Kandorp et al. 2022 paper actually produced a model to look at the annual mass that ends up on the beaches in the Netherlands. And so this is, the first time that there is this kind of these numbers that can be applied to such a model to try to really look at the overall picture. And so here you'll see a schematic of everything that I mentioned in the Sankey diagram. But yeah, here you actually really see how much is unreported. And I really wanted to focus on the fact that this import and export, there is very little information about the destination of this import and export of plastic scraps. So if there's very little in the Netherlands, you can imagine in other parts of the world. So there's this huge amount, 623 kilotonnes in 2017. And there's very little information about what happens to this waste in the Netherlands. And then out of the amount that is actually exported, there's very little information about how much of that was originally from, for example, the imported waste and then became exported waste, or if it's really Dutch waste that is being exported. So that's why there's this really large amount that's unreported here, and then a large amount that's unreported once it reaches the destination countries, so the countries that are importing the waste. But this is, you can imagine that this was a very long paper with a lot of, the methods section is really long. So if you're interested, then you can definitely contact me, and I can share more information. Now, I also just wanted to show that because Audrey mentioned that I look at the transport of plastic waste, and normally it's really based on modeling just in the ocean. I also just wanted to mention that the latest paper that has come out based on the work that I've been doing in my postdoc for the last 2 or 3 years. Is on biofouling. So this is when you have the attachment of algae on microplastic, and it can cause the plastic to sink. So it can affect the 3D transport of microplastic in the ocean. And so we were looking at the combination of this biofouling with other variables and other processes in the ocean. So, for example, looking at the wind component and wind mixing. And so you can look this up, and this is just to show you, this is just to show you, for example, I'm sorry, it keeps going back. Ooh, sorry. This is just to show you, the main results that we found. So we were looking at different regions, for example, that had different biological and physical variables, and they were very characteristic of those different, those different regions. And so, yeah, you can basically see when there is a lot of biology, a lot of algae in the ocean that will cause something different to if there's a lot of mixing, for example, in the Southern Ocean, and you'll have a very deep mixing layer. And so you can have a lot of, you can have this will change the vertical distribution of the particles. And yeah, finally, I see that I'm running out of time a little bit, but I also just wanted to show a fun animation of a project that some of us from my research team took part in. So this is the Blue Cloud Hackathon. So the Blue Cloud is an online platform where they have virtual labs and they aid different projects by providing data and providing a platform where you can run your simulations and everything. You can also look them up. And they held a hackathon in February of this year. And one of the outputs, so we put a team together and we were happy enough to win the hackathon. And so we are working on this project that is looking at the effects of plastic pollution on and by aquaculture farms in the Mediterranean. And so this is just a quick animation to show you that you can click on an aquaculture farm. So these blue dots are different locations of the aquaculture farms, and then the simulation of where the particles are going. And we want to look into whether these particles can end up in marine protected areas, for example. And so, yeah, we're working on this for the next couple of months. And yeah, so I'm sure that you'll see things on Twitter if you're on there, and you'll see where this goes to. And the very last thing, sorry, Shia, I realize I'm going over time, but because Audrey is also here, the two of us and Siggy Gruber, who is a former EU Commission officer, we created this network that is called Ocean Bridges. And if you want to learn more about it, then you can click on, well, I don't think you can click from there, but you can basically copy paste this link. Or you can go on the QR code, and this will bring you to a form where you can fill in your details, and then you will get more information in the future. But we're basically trying to create a network that is bridging or facilitating knowledge exchange between early career ocean professionals and experienced ocean professionals. So those that can provide help with their networks and their knowledge of the system, and we can help them with, you know, technology and other innovative ideas. And yeah, so there we go. Sorry, Shia, and thank you everyone for listening.
Right, thanks, Delphine. Yeah. So Yuta, can you share your screen?
Sure. Can you see my screen?
Yes.
Right. Hi. So I'm Riora, and one of the organizers was OPW. Great. So today I'm going to share with you some of the results from a recent work on the plastic debris in the deep sea environment around Japan. Okay, here we go. So as Delphine mentioned earlier about mismanaged plastic waste, so plastic leaks into the sea from land. Most of them are mismanaged plastic waste, and the number of mismanaged plastic waste has been estimated somewhere between like 60 to 99 million tons annually, and these are available into the ocean via through rivers by helping wind, rain, runoff. And Asian country represent more than 60% of the mismanaged plastic waste in the world. And as you can see in this figure, a lot of the countries in Southeast Asia and East Asia possess a large portion of mismanaged plastic waste, which is shown in red in relation to the total plastic waste production. And there are some estimates of leakage rate of plastic waste into the environment. For example, the plastic leakage into the aquatic ecosystem has been estimated like 19 to 23 million tons. And another study showed that leakage rate solely into the ocean is somewhere between from 9 and 14 million tons. And when you look at this figure of 9 to 40 million tons of plastic available into the ocean, then a question arises as to where the most of plastic go after entering the ocean, which is also called the problem of the missing plastics. So long story in short, the annual plastic waste leaked into the ocean. So this is just one estimate that is 9 to 40 million tons. It's by far higher than the actual amount of plastic floating on the ocean surface, which has been estimated somewhere between 400,000 and 500,000. So we could say that the majority of plastic is missing, but plastic goes somewhere, certainly go elsewhere. But recent studies have shown that the plastic obviously went to the deep ocean because the quite few numbers of microplastic fragments were found in the wide range of seabed flora. And the recent study also have been clarified that a lot of debris is actually accumulating, but we haven't yet we haven't reached the conclusion about how many plastic is accumulating in the deep sea floor and how they reach to the deep ocean. And the most important thing, we haven't found a super large number of the plastic waste on the deep sea floor to explain the missing plastics. So that's why we study the deep sea floor around Japan. It is not because we are based in Japan, but also because the most of the plastic is coming from the Asian continent. So as you can see, these figures, a lot of debris is transported from these massive waste producers via ocean currents such as Kuroshio. And Japan is located in the area where the large amount of plastic debris is coming to this area. So Japan could be a hotspot of plastic debris. So then, and previous study actually have revealed that Japan could be a hotspot of microplastics. So this figure shows the abundance of microplastic floating in the ocean surface in the seas around Japan, and also this is the average of North Pacific and average of world ocean. And please note that the X scale is log scale. X-axis is log scale. So as you can see, the abundance of floating microplastics in the seas around Japan is by far higher than the other oceans. And the same situation may be true for the deep sea plastics. So we are suspecting the huge amount of plastic debris is actually hiding in the deep sea flora around Japan. But so I'm gonna show you the photograph or the video that taken in the deep sea in the Sagami Bay, Japan. This video was taken in 1,000 meter depth, and as you can see, the plastic bags is like drifting in on the seafloor, and I guess the deep sea fish is watching the trash. And also, I'm gonna show you a different photo, but this is what's taken on the deep sea floor at a depth of more than 600 meter depth of the coast of the Tohoku, Japan, where tsunami had happened. So after the devastating event, this kind of the plastics was accumulating on the deep sea floor. And you can see the red fish in the center of the figure. And this is a very expensive fish, but I guess this fish has no choice but to eat plastic accidentally. And so that's why, but the deep sea is very vast and huge. So we need to find a hotspot on the deep sea floor where the plastic can accumulate. So there are two, in my mind, there are two suspicious garbage reservoirs. So as you can see in this figure, so you can see the Kuroshio current here, and there are two areas where it is warring widely and making a big vortex and or gyres. So we are suspecting a lot of debris that transported via the corrosion current can captured in the center of these gyres. So we're suspecting that a lot of debris can be sunken and hiding underneath these gyres. And so when I visited the corrosion extension recirculation gyre, actually we found a large amount of debris was floating on the ocean surface in the center of these gyres. So we are suspecting a huge amount of plastic is also lay on the seafloor underneath this gyre. So that's why we dived the accumulation area using Shinkai 6500. That is a man-made, man-submergible deep sea platforms that can go up to 6,500 meter depth. So this is me. So I dived there, and this is the map of the dive sites. So we dived these 3 sites under the crucial extension recirculation gyre. We are suspecting a lot of debris accumulating, and the depth was like 6,000 meter depth. So which is called abyssal plain. And here is a photo from the survey. So as you can see, this is a plastic bag, and I have to tell you that. So when I dived there and reached the sea bottom, I noticed that finding the debris was so easy. And I clearly remember the conversation with the 2 pilots, like, oh, there's plastic again. Oh, more plastic there, like, so plastic's everywhere. So when you move the vehicle, so this is very dark, so you can't see all the seafloor, but you can see the like 5 or 6 meter ahead of you, and every time we moved a little bit, you can find a plastic like this one, like plastic bags, and the plastic bags was the most dominant plastics in the deep sea bed here. And can you guess what this is? So this is a balloon debris, and I think this is a Valentine's Day's balloon, and this is like aluminum foil balloon, but all the aluminum coating had decomposed, and inner plastic film was bare. And as you can see on the surface, it reads, "I always want more love." So we are suspecting this is from Valentine's Day balloon, but it also comes with a starfish here. So I would say it's starfish who needs more love, right? And so here's the results of the number of plastic debris we found, and the average abundance of the microplastic lay on the deep sea floor was about 4,500 meter items per square kilometer. And when you compare it with the other deep sea structures, deep sea bottom structure like seamount, canyon trench, or like reach, and this pink line indicates the median value of the previous researches. So this is this is the review and including almost all the previous researches. So when you look at the median value, the abundance we found on the underneath the corrosion extension is way higher than the other bottom structures, especially when comparing with other abyssal plain. So this is a world average, a world median value of the abyssal plain, which is 2 orders lower than we found in the corrosion extension. So actually, we found the hotspot of plastic debris in the seas on the deep sea bed around Japan. So this is the 2 last slides. So we also found very interesting garbage. So this is the photo of the chicken steak packaging, and this the dated September 1948, which was like 35 years ago when at the time of collection. So, and also this one is the toothpaste tube was dated back in 14 to 15 years ago. So these are very interesting example of the persistence of plastic debris in the deep sea environment, because the UV light or the temperature is completely missing or very low for the temperature. These factors are like main factors to degrade plastic, but these 2 main factors are completely missing in the deep sea environment. So deep sea once it gets in the deep sea, it persists for very long time. So now you may think that maybe marine biodegradable plastics can be the solution for the deep sea plastic accumulation. But truth is, even the marine degradable plastic, it is really hard to decompose in a deep sea environment. So that's why Jamstack now has a project to critically estimate or evaluate of deep sea degradability of biodegradable plastic. So we collect every trade secret biodegradable plastics from manufacturers as much as possible and put them into the special chamber and put on the Shinkai, like deep sea submersible, and bring them to the deep sea floor, like 800 meters or even more than sometimes more than 2,000 meters. And we visited the sites 2 times a year to check the degradability, real deep sea degradability. And I cannot say the details because it's secret, but I can say so when I check the degradability, so some of it claims the marine biodegradable, they still studying the breakdown. It's so okay, it's okay, but some products, it's totally not starting degrading. So it's a fake marine biodegradable plastics. So we have to watch it for a long time. Yeah, that's all my presentation. Thank you very much.
Great, very cool, very cool research. In the deep sea environment. Thanks again, Hibeta. Yeah. So as last talk, so Dr. Takenta. Hey, Takenta, can you share?
Hi. Yep. Doing that now.
Great.
Can you see it?
Yes.
Okay, perfect. So I don't have much time, so you guys can manage to ask your questions. So I'll give it's a pretty brief presentation. And in this research, we want to take a more strategic perspective on the issue of plastic leakage, in that we weren't necessarily focused on the quantification and the tracking, but more on the what do we do about it aspect of it. So we asked a question as to whether leakage rates can serve as a proxy indicator for potential marine environmental impacts to inform the life cycle management of plastic products. And what I'm presenting on is from a published paper in 2021, so it is available online. So in this work, we wanted to see what the feasibility and influence of integrating leakage rates, which we defined as a fraction of waste generated flowing in the marine environment, into the life cycle management of products involving plastic as a material choice. So if you're looking into product redesign as a company and you don't know how to account for the marine leakage impacts, then you could possibly use leakage rates as a proxy. And then we had to see the potential influence. We had interviews with key value chain actors, where we actually presented them with the information. We found out how they generally make decisions when it comes to plastic leakage, and how having information on product-specific leakage rates might change the way they approach things. So looking back on what the usual modus operandi is, they decide the prioritization of products for intervention in different ways. So they might look at how available are different material alternatives, which is seen as a quick win. So for the plastic straws, we're like, well, you can get paper straws, so let's do that. Consumer pressure plays a huge part. So if the consumer is very vocal about a certain product, they're most likely to provide an intervention. They also look at foreign markets. So in South Africa, we would look to Europe and see what's happening in Europe in anticipation of the same pattern happening in South Africa. There's only one value chain actor that we spoke to that actually looked at what was considered a major contributor to marine pollution. So they looked at those dirty dozen lists, but they complained that they're very inconsistent and they vary so widely from place to place. It's difficult to use them. And the other factor used was volume based. So they believe that if they intervened on a high volume product, this would make a big difference. But just because it's a high volume product doesn't mean that there are high volumes going into the marine environment. So that could potentially sideline items that really are major contributors to marine pollution. So like we said, we used beach accumulation rates. So beach survey accumulation rates is a proxy for marine leakage. And you can see beach survey rates are difficult because they are influenced by a number of things. So things like the climate, the water movements, the catchment area characteristics, the population density, all make a difference. So when we did that for Cape Town in 2017, we had ranges of 36 items per day per 100 meters going up to 2,900. But when we looked at, what are the materials that are there, we found 10 items that are prevalent on all beaches. So you're guaranteed to find your biscuit wrappers, your cotton bud sticks, your bottle lids, lollipop sticks and wrappers, those polystyrene clamshells that we use a lot for food, polystyrene cups, straws, snack packets, or chip packets, and those little single sweets that they give in restaurants, with the bill. We found a lot of those wrappers. So to calculate our leakage rates, like I said, leakage rates are a fraction of waste entering the environment. As a percentage, this is the total accumulation rate, so based on our beach surveys, over the waste generated. So the waste generated, we used the quantities sold from direct sales data, which provided an indication of consumption rate. So we could use it as a proxy for waste generated. And this also worked because these are short-lived items. So a single sweet wrapper will rapidly become waste. So this would not necessarily work for long-lived items, such as plastic furniture. So the leakage rates we found that you could then look at high prevalence items and low prevalence items. We split it into that. So it seemed that items that are used for consuming food on the go had a higher prevalence than low prevalence items where you use food in the home. So for example, your lollipops, you eat a lollipop on the go. You don't sit down and eat a lollipop unless you do, no judgment. That had a high prevalence and relatively high leakage rates with 84% for lollipop sticks. However, for your margarine tubs, that had leakage rates of under 5% because you're likely to use it in the home. And here in South Africa, at least we reuse the margarine tub, and when we're done, we're going to put it into our home trash. So it's unlikely to be leaked. But an issue with the leakage rate was the standard error. There's a high standard error, which comes with the fact that beach accumulation surveys have a lot of error associated with them due to the high variance that's observed for different areas. Even the day-on-day variance is quite high. However, so the value in the leakage rates was looking at which one is highly prevalent versus it's 83%. So from this, you can say, okay, my beverage bottle lids are a problem. They have a higher prevalence than, I don't be focusing my energy on this actually. So that's where the real value lies and not so much in the percentages. So at the end of the day, when we asked our stakeholders, here are leakage rates, are they helpful? And for them, they provided a more realistic understanding of the relative leakage propensities of different items. So they weren't just going on the 30 dozen lists, but they could actually say, oh, these list of items, I can see which are the bigger problems that should be prioritized. And at the end of the day, product-specific leakage rates provide a valuable evidence base for the identification of problematic items for more targeted interventions when it comes to marine plastic pollution. And that's it from me. Thank you very much. This work was conducted at the University of Cape Town and was supported by South African National Research Foundation. Thank you, Shir.
Thanks, Dakota. All right. Okay, thanks again for your interesting talk. And that seems we have some question here. And also we have entered the time override. So we will have 10 minutes to answer the questions. So let's see. Okay. The first question is, I think, it's for Audrey. So what's the global coverage of the GEO Blue Planet? And you mentioned head of office in the US and EU. So does this mean that activities are only focused in this area?
Thank you, Xie, and thank you for the person who asked the question. What do you think, Xie, if I answer all the questions for my talk, and then we can move on maybe to Delphine and Ryota and then Takunda? Maybe that will be faster, more efficient, since we only have 10-15 minutes for the questions. And sorry again for I took too much time while speaking. So the global coverage of GeoBlue Planet is actually, sorry, the coverage of GeoBlue Planet is global. As I presented only, one action of the many that we do at GeoBlue Planet, imdust is global. Like we're looking at everywhere. So it doesn't mean that we basically go where high-level stakeholders like the IOC or UNEP tell us to go. So it's mainly global, but we also look at more regional issues such as sargassum, that's the Atlantic tropical band, or oil spills in the Caribbean. So it really doesn't, it doesn't really matter so much where the offices are. And also I forgot to say that in this year, in a few months, we will have a new office in Korea, at the Korean Maritime Institute, KMI. So we'll be, a little bit more representative of the global aim of GeoBlue Planet. If you don't mind me jumping to the next question, which was the digital platform, what is exactly the goal of this platform? How can it be available to people who is interested in? So the digital platform from GPML. So GPML again is the global partnership on marine litter from UNEP, that is the UN Environment Protection. And this platform. So the aim of this platform is to get all this data we have from observing marine litter, but also the entire life cycle. So it's more linked to what Takunda was showing, and even Delphine is like where plastic is produced, where it's transformed, where waste management is not, good enough, and so on. And from all this information, they will, transform this data actually into information, of course, based on, experts and so on, to help not only, as I was talking about, the creation of this binding agreement for UNEP, but also for scientists and so on. So this platform is in a beta version, and it is online. I will share the link, and yeah, if you basically type UNEP GPML digital platform on Google, you will find it. And I think that was it for me.
Yeah.
Is that right?
Yeah, I think so. That's
okay, good. Then I will.
Planning. Thanks, Audrey.
Thank you.
Shall I go next, Xie?
Yeah, I would like. Yeah, there's some question for you, David. So yeah. So the first one have been see clearly, right? See clearly is very cool. Is this calculating trajectory online, or is it displaying pre-computed trajectory?
Yeah, thanks a lot for the question. So for a recap, See Clearly is the project that we're doing based on the hackathon, the Blue Cloud hackathon, and looking at impacts of plastic pollution on aquaculture cages. And yeah, currently it is pre-computed trajectories. So hopefully maybe sometime in the future, it can be that, you click anywhere and the trajectories go, but for now it's pre-computed.
I have a question about this program. So you simulate the plastic dispersion based on the agricultural cages. So I mean, what type of the particles did you assume release from these aquaculture cages in the model?
Yeah, could you just ask the question one more time?
Sorry. So I mean, this model is based on want to simulate the particles releasing from these agricultural cages, cages. So what kind of particles, what property of particles are you using in the model?
Yeah, for now it's just microplastic, and it's it's basically we're not really adding any properties or anything. It's really just kind of a particle that moves with the currents. So it's we're not looking at a specific chemical property, for example. Yeah.
Okay, good. Yeah. So okay, so.
Yeah, I guess my next question was about the 0.2 to 1% of leaked plastic and the number in kilotons. And
Yes.
so the number in kilotons is between 4 and 23 kilotons. So this is, when you look at the total amount that has been generated, we were just looking at what proportion of that actually leaks into the environment.
Great, David. Yeah, we will turn over the time to Yuta.
Yeah, sure.
So, Yuta, do you think there is more plastic around Japan, or it's just that it's underestimated along all the other coasts? That's a question from Audrey.
Yep, thanks for the question. Yeah, I believe there's much more plastic hiding in the deep sea bed around Japan, because Japan is located in the area where the massive waste can be transported via cross current from the massive waste producers. But also the underestimation along the older coast is also possible, because the investigating deep sea is very costly, and we can observe the very small area of the deep sea. So we need more like innovative technology to find out the deep sea plastics, to find out where the missing plastics.
Can I just jump in for a follow-up here? Because I've seen like very similar images, not as deep, but between France and Corsica in the Mediterranean Sea. Have you compared observation made by similar, like roves, to what you're doing in Japan? Because it just seems to me odd that, like just where you're looking, there is more than everywhere else. It just seems that you're the only one looking somehow.
Yeah, okay. So Mediterranean Sea is like kind of like closed area. So the debris easily can be accumulated. So it's easy to imagine that a lot of debris is hiding on the deep sea floor in the Mediterranean Sea. But Japan is like kind of like in the open area. So a lot of debris can be swept away to the vast Pacific Ocean. And when the area where I investigated, like some 500 kilometers from the coast of Japan, it's very far. And usually the people believe that the less plastic find in the with the increased distance from the coast, and more plastics to the near coast area. That's the the hypothesis that people believe. But the study I found that it's totally opposite. More plastic found in the far away from the coast. So that's still so. That's why I believe that Japan is, or the sea near Japan is we find hotspot of plastics. Thanks.
Okay. So I have a question for you, Yuta. So yeah, I see your slides. One slide you show the numerical concentration of the plastic items, from different geography, location. So did you transfer this concentration into the the mass concentration? Because we focus on the large plastic, so the mass balance should be much more important than items.
Yeah, that is a very important point. And converting plastic number to the weight is very challenging study. But I also tried to estimate the mass of plastic waste using the average weight of the plastic weight. Then but still the whole plastic weight I found in the area didn't represent the missing plastic. So I'm feeling that we need to find more areas to find out the hotspot in the deep sea.
Okay. Thanks to you, Tom. Yeah.
Thanks.
So
I also have one question related to my question. Can we answer quickly?
if you want.
So thanks. This is where is it?
I think you mean the very disturbing photos? What's the?
Oh yeah, that's one. Yeah,
Yeah.
Thanks for question. So what is the sedimentation rate on these abyssal plains? Do subsurface redox condition change degradation rates? Yeah, thanks. So we simulated the sunken rate to the deep sea floor. So the distance was like about 6,000 meters, and just 1 week it's good enough to reach to the bottom from the surface. This estimate was based on the real incubation of the macro debris on the sea surface. So we incubated the plastic debris on the surface of the coast water for about half year, and to make the plastic highly coated by the biofouling, and even the thin plastic film that can float on the surface can sink to the bottom after half year. So we check the sinking rate with the stopwatch, then convert the number to the supercomputer, then get the result. Just 1 week to good enough for reaching to the depths of 6,000 meters.
Okay.
And also the redox condition, yeah, that works for the surface, of course. Thank you.
Okay, thanks. Yeah, so they have a question for the Takenda from the Audrey. So the differences in the prevalence could be linked to the education. People associate bottle with cycling, but not so much the cigarette, bars, and lollipop.
Thanks, Audrey. So it is linked to education in the terms of how people behave, so the behavioral properties that they have. So I would say, some people grow up in a culture where they don't know that littering is harmful, right? So they don't learn about don't litter, recycle, all of these things. So that's an issue of education because they don't know the harm that they're doing, which is why there's a lot of focus on education in primary schools at the moment on littering. But then with a beverage bottle situation, I think it's more behavioral because when people are walking with a beverage bottle, they'll undo the lid and they'll toss it. And the bottle, they might drop it. And because we have waste collectors, the waste collectors will pick up all the bottles that are dropped in the street. So it's not that they're not littered, but they're more likely to be recovered because of their high recycling rate. But yes, education is definitely part of the problem. Thanks.
It's just so interesting how, different parts of the world actually treat litter differently. That it just makes sense that, if someone comes after you and, makes money out of it, you're just going to drop it on the street. Yeah. It just makes sense. But then this entire system didn't take into account that, wind will just take this water bottle away. And that, of course, as you're saying, some litter have more value than other litter. So there will be some sort of like, do we say triage? Some sort of like sorting of the, that's very interesting. Thank you.
Okay. Yeah. Also, we still have some question, but we actually don't have time. But if you have some question, you can send us the OPW emails. And yeah, that's all. I think thanks again for our 4 co-founders for answering this question and for their great presentation. And thank you, everyone. We appreciate you being here. And thanks again for joining us today. We will see you next time.
Thank you, everyone. Thank you, Xie, for moderating.
Yeah, thank you, everyone. Thanks for question.
Bye-bye.
Bye-bye.
Bye-bye.